Okay, good morning, and we're going to be looking at observing chemical reactions, just a quick theory and a reminder of what you're supposed to be able to do for this week. We can tell that a chemical reaction has taken place by gas evolution, and that of course is bubbles or fizzing, a temperature change, and that you can usually feel with your hand, although one of the temperature changes is going to be significant enough that we're going to have you hold it with a test tube clamp. Color change and a precipitation. Now, precipitation you can frequently see by your solution going from clear to cloudy. It's not going to just kind of plump, sit there in the bottom of the test tube unless you centrifuge it. It's going to become cloudy like colored milk. All right, so far what we've done in Chapter 3, what you should have done to date, have watched the videos, first 3 lectures in Chapter 3. If you're not there, you're in trouble. First lectures, 3 lectures in Chapter 3, we did chemical equations and we did balancing, which we're going to check out here today. We talked about electrolytes and solubility in water, whether something's a precipitate or not. Then we went on to talking about metathesis reactions, which are also called ion exchange, and our complete ionic and net ionic equations. Finally, at the end of Chapter 3, Section 3, we were looking at acids and bases. Now, the next section in Chapter 3 talks about a couple of the reactions that I'm going to introduce to you today. So the reactions that you're going to see are combination or synthesis. Now that's one of the reactions that I told you you didn't need to be able to figure out the products of. You needed to be able to identify and balance it. So we're going to start out by balancing this one. This is an easy one. If I look over here, I've got 2 irons, and I don't have any over here, so I'm going to put a 2 here. Now, oops, that's not helping, because now I have O2 here and O3 here. And remember, my balancing numbers, my stoichiometric coefficients cannot be fractions. And so I've got a problem. Let's see. I can make this be the same number by having 3 here and 2 of these. Okay, so now I have 6 oxygens and 6 oxygens, but I have totally messed up my irons. So I need to change my irons, and that's very easy. I now have 4 irons, so boom, we're done. That's a balanced equation. Another type of reaction we're going to see today is decomposition. Decomposition is where you have one product, where you have one reactant becoming 2 or more products. Forgot to mention for combination or synthesis, you have 2 or more reactants becoming one product. So for decomposition, my example here is the formation of KCl, an oxygen gas, from potassium, which one is it? Chlorate, potassium chlorate, right? Chlorate is COL3 minus, potassium chlorate, polyatomic ion. All right, this is one of those unusual situations for you so far, in that chlorate's actually going to break down during this decomposition. So this is a decomposition, one reactant becoming 2 products. Let's balance this. Well, we already figured out above that when you had a 3 and a 2, you had to make 6. So we're going to do that. So we need 2 of these to have 6, and 3 of these to have 6. So now that our oxygens are balanced, let's figure out the rest of it. Oh, this is easy. I just need to put a 2 there. So now I have 2 potassiums, 2 chlorides, and 6 oxygens. Okay. So moving along, the next type of reaction we're going to be looking at today is our metathesis reaction, which we've already done in lecture. And these are our ion exchange reactions. Now I've got a couple examples of each. So far in lecture, we have done this one. We're about to do this one. And these we have yet to do in lecture, but we're going to introduce them today. So let's go ahead and take this and walk ourselves through the steps to figure out the product and then our complete ionic and net ionic equations. So we have sodium, and what's that polyatomic ion? Sulfate. And we have calcium chloride. Both of these are aqueous, okay? So our first step with figuring out the products is to write these as ions. So 2Na plus, actually we don't need to know that yet, and we have sulfate, 2 minus, and I'm going to skip our aqueous for right now, and calcium 2 plus, and chloride for right now. We're not going to worry about the numbers, just the type of ions. Our second is swapping them. And I'm going to swap my anions, so I'm going to take my chloride and pull it forward with the sodium, take my sulfate and pull it back with the calcium. So I have Na plus, still I didn't move that, chloride, and I now have, I didn't move my calcium, and I have my sulfate that I pulled back. My next step is crossing over, and when I do, I just get NaCl, and I get, oh, this is nice, I can just bump those two together and get calcium sulfate. Now I'm going to check for products, and remember, our products are water, or carbon dioxide, or a precipitate. So you're going to take your solubility table from your lab and look these up. Well, when you do, you know table salt is aqueous. Calcium sulfate is actually, I believe, plaster of Paris, and it is a solid, or your walls would dissolve every time it rained, which is not a good idea. So we now have, we can see that we do have a reaction because we got a product. So we can see we have NaCl, aqueous, and calcium sulfate, solid. So this is our product. All right, so now we're going to move on, and we're going to do the next part, which is our complete ionic and net ionic equations. Now we know we can do these because we're dealing with ions, ionic compounds. So for our complete ionic equation, oh gosh, I should check and make sure it's balanced. Let's see, 2 sodiums, 2 chlorides, it's not balanced. So I'm going to put in a different color, 2, right? 2 sodiums, 2 sodiums, 2 chlorides, 2 chlorides. Phew, lucked out with that one, I remembered in time. Calcium, 1 calcium and 1 sulfate, so we're good over here. Okay, my complete ionic equation, I'm going to break these down, and now I care about how many ions we have. So 2 sodium plus, and a sulfate. Remember, polyatomic ion, we keep it together unless it's a decomposition reaction. And our calcium 2 plus, and our 2 chlorides. Now notice, this is exactly what we just wrote, except for now we're including the number of ions. So over here, the thing that's aqueous, we break up. 2 sodium pluses and 2 chlorides. How do I know it's 2? Because I have 2 NaCl's. So I have 2 of the whole thing. So 2 sodiums and 2 chlorides, and then we have our product, which is a solid, so we leave it together. So that's our that's our complete ionic equation. Our next step is that we want to know our net ionic equation. And in order to know our net ionic, or get our net ionic equation, we have to get rid of our spectator ions. Spectator ions, remember, are ions that don't participate in the reaction. They're the same on the reactant side and the product side. So let's see, here's one, sodium, gonna get rid of it. And here's one, chloride, gonna get rid of it. So now our net ionic equation is what's left over. So sulfate and calcium becomes calcium sulfate solid. Okay? All right, so that's just a reminder, just a refresher of what we're doing, I hope. Let's do this one. This is using our strong acid, strong base. So HBr, aqueous, and KOH, aqueous, yields. First of all, we're going to break these down with our ions, H plus, Br minus, K plus, OH minus. Our next thing is we're going to swap our anions, H plus, OH minus, K plus, and Br minus. Now we're going to cross over, we get water. Hey, I don't even need to look that one up. I know that's a liquid, I know that's a product. That's the driving force for a neutralization reaction. And I also get KBr. And if I were to look that up, I would see that's aqueous. Can you stop it and then we can start it again?
Probably.
Pause it or something.